Okay, Christy.
Yeah,
How are you, mate?
I'm fine, and you?
Great. The good thing is that you asked me something really interesting. There are two ways. It's an answer. It's a question that has two answers. Okay. PBS. PBS is a binary ionic compound, a topic that I taught last year. Okay. And I gave you this periodic table. Okay. That I say that we can use it whenever we form ionic compounds. And for example, even here in red, it is highlighted in red, S2 minus. The ion here, S2 minus, is the one that we know as sulfide ion. It is an ion that is used only in binary compounds. That's why it ends in IDE, sulfide. So the ion sulfide uses a charge of -2, the same as oxygen. That's why it is located just below oxygen in the same column, okay? So it has pretty much, well, similar characteristics as oxygen in terms of oxidation state. So when you have a binary ionic compound, sulfur is actually sulfide, and it's gonna have a charge of -2. Okay, it's just gonna have a charge of -2. If sulfur is -2, then lead, which has two choices, and you see no other sulfate in the bottom, then PV lead is gonna be 2 positive. Now let me show you something else. Okay, so we have PVS. Okay. So because this is a binary compound, actually this is never going to be just sulfur, okay? This is not going to be sulfur when it's ionic. It's always going to be sulfide. And the ion sulfide always has a charge of -2. Therefore, for it to be balanced, this one needs to be 2. In this way, you get the 0. It is balanced, it is electrically balanced, and this is what we're looking for. So whenever you see sulfur in a binary compound, binary ionic, because lead is a cation, okay? So it's going to be binary ionic compound. Whenever we have a binary ionic compound, sulfur is actually sulfide. And it's going to have a charge of -2. Then you said exercise number 5. I don't know who said it, but someone said exercise number 5. What do you want to know about the 5?
No, Miss, exercise number 5 is where PDS was, so thank you.
Oh, okay. But I remember someone else asked me something about the exercise 5. Belen.
Miss, for example, I have this question when there are like more than 2 elements, right? And two different elements can be in the reduction, can be reduced agent. Which of both we choose, and how do we know which to choose?
It could be better if you could be more specific about the exercise.
For example, in exercise, let me see.
8?
No, for example, in exercise 3, it's not so like that, but for example, we don't have like an oxidizing agent because there is no element at least of how I solve it, it's not element that it's
Okay.
more than.
Okay.
In,
And you said the exercise 3.
yes.
Okay. KClO3. Producing KCl and O2. Okay. So we get the oxidation states. This is -2. This is 1. This is 5. A ver, just to confirm, -6 and 6 makes the 0. And here, this is chloride ion. Therefore, it's -1. Therefore, this one is 1. Okay. And O2 is 0 because it's a pure element. And so from here, you're able to notice that we have oxidation and reduction. So where do I have reduction? Reduction, I have it here. I have a reduction in chlorine because we had chlorine 5, and afterwards we have chlorine -1. Okay, so here we have reduction. Then we have oxidation. Where do I have oxidation? Oxidation is here. Why is that? You can see this from the perspective of a number line. Okay. Bueno, ni modo. Quedó feito. So this is 5, 4, 3, 2, 1, 0, -1, -2, -3, -4, etc. Okay. So I have reduction because first chlorine was located here in the position 5, and just afterwards it ended up in the position -1. So this oxidation state moved leftward, which means that reduction occurred. When in the number line you have this kind of motion to the left, for example, we say that we have a reduction. That is the case for chlorine, which is very obvious. But then we have oxidation. In oxidation, we had initially oxygen located at -2. So I'm going to use yellow for this, okay? So initially, my oxygen, sorry, was located at here at -2. And then it moved to the position 0. It moved 2 spaces to the right, which means that the oxidation number was increased because the type of motion on the number line is to the right. Because the oxidation number got increased, we say that this is oxidation. Or think about a depth, okay? Think about a depth. You owe me 2 lempiras, okay? And After today, you're gonna pay for me. Okay, you're gonna pay me those 2 lempiras. So your debt's going to end in 0. But in the end, you don't have a debt which is a negative value, okay? You have no debt, which is amazing. I mean, you might not be rich, but at least you have no debt. So here happened almost the same, okay? So it was negative and it ended up at 0. But in the end, what you have is an increase in the oxidation state, because on the number line, the oxidation state moved from the -2 that we have over here to 0. That's why we say that this is oxidation. I don't know if I answered your question and you understood.
Yes, Miss, thank you.
Okay. Is there any other question about the homework? Karen?
Yes, in exercise number 4, we have 3 oxygens, right? And one oxygen is 0, and the other 2 of the products are -2. So in the reduction, which is the oxygen I'll be used for the reduction?
Okay. You said the exercise 4, that is NH3 plus O2. We have NO and we have H2O. So the oxidation states are 1, -3, 0, -2 and 2, okay, -2 and 1. So my oxidation, okay, is for nitrogen, okay? Nitrogen is oxidizing because the oxidation state increased. So I know that this is oxidation. Okay. And I'm not gonna use this oxygen in the reduction because now it was taken here in this part, okay? Because this oxygen was already taken here in the oxidation part. I'm not gonna use that oxygen. Therefore, the oxygen that I'm gonna have to balance is gonna be this one over here. From 0 to -2, I will say that this is going to be my reduction. Why? Because this oxygen 2 was taken in the oxidation part because of the nitrogen. That's why.
Thank you, Miss.
Okay.
Miss,
Wait. Okay. Angie, then Sarah.
in the exercise 8, there when we balance, there's a missing a digit, and we have I don't know if
No,
you
it's
can.
okay. I balanced it.
For example, if we have in solve for 3 and on the other side we have just 2, it will be correct.
What? I have sulfur -2, and I have sulfur 4, and I have sulfur 0.
No, at the moment of balancing, the normal balance in the period
Okay,
balancing, we use-
wait. In the balancing part,
Yeah, we need to balance sulfur.
yeah, it's true. You're gonna see, that one is interesting. The number 8, I think the number 8 is the most interesting exercise from all the homework, because the 7 is overwhelming because you see it's huge, but in the end you can do it in one step. And the 8 is interesting. But yes, you want me to do it or what?
You like it, so do it. And also I want to
Come
do
on.
number 10 because I think
I
there's
know, I'm not gonna do the 10.
I prefer you do the 10 and not the 8.
Number 4 and 5.
A ver, the 10. They said that 10 requires an adjustment at the end. But it's not, I think 8 is more interesting than 10, a lot more.
I think that the interesting part of it is that there's a missing a digit that we
No.
really do it.
Gosh, bye, pues.
I will give you this gift.
Espérese, pues. Give me a moment. Okay, we have the 8. We have. I lost my whiteboard. Wait, aquí estoy. Okay, so this is the 8, right? Yeah, right, this is the 8.
Yeah, this.
Okay, so I have this charge, -2, 1. I have 1, I have -2, and I have 4. I have 4, yeah. Okay, this is sulfur alone, which means it's pure sulfur, which is 0. And then we have 1 and -2. Okay. So in here, you're able to notice that we have reduction here and here, because sulfur was 4 and afterwards it was 0. So the oxidation number was reduced. So we have reduction over here. And the oxidation occurs when the other sulfur that was negative ended up with a value of 0, which means that this is the oxidation.
Miss, so oxidation and reduction can occur with the same element as in this case.
In this case, yes, it happens that sulfur from the sulfide ion was
For
reduced.
example, I guess at a number
Sorry,
6,
was oxidized. What are you saying? Sorry.
and the number 6, I guess that happens the same. Well, I'm having another doubt on this one too.
In the 6.
First finish with this.
No, it doesn't happen. It's the same. I mean, bueno, it's the 6. Okay. Está bien, the 6. So you have your reduction and your oxidation, and yes, it is the same element. Okay. So what do we need to do? Just you do the redox part. It is important that you balance if needed. Okay. So you have in reduction, you have S with a charge of 4, and it ended up with a charge of 0. It is already balanced, so I don't need to balance any substrate, any number of atoms. So I'm just going to add the number of electrons. From 4 to 0, I have a difference of 4, so plus 4 electrons over here. In oxidation, I have S with a charge of -2 or sulfide, producing pure sulfur. Okay, so from -2 to 0, we had a distance of 2. Okay, so here I'm going to have +2 electrons. In order to have the same number of electrons in reduction and in oxidation, I need to multiply oxidation times what number?
2.
Okay, so this gives you, okay, the first remains the same, S4 plus 4 electrons, producing S0. And in oxidation, we have 2 times S, 2 sulfide, producing 2 pure sulfurs plus 4 electrons. We get rid of the number of electrons with number of electrons. And we're going to add. Now take a look. These 2 sulfurs are different because they have different charges. But these 2 sulfurs from there, they are the same because they have the same charge. So this is our invisible one, okay? And what we can do is we can add these 2 together because the only reason we do that is they both have the same oxidation state of 0, okay? So we say, when we add, we say 1 plus 2 give us 3 sulfurs, okay? In this case, we cannot add them because they have different oxidation states. So you're gonna have S4 plus 2 S to the minus 2, okay? This is how you add them. I already got rid of the number of electrons because they were the same, and I'm lazy and I like to do it in that step. And then all I need to do is I need my original equation, and I'm going to include the coefficients. So here in the sulfur with a 0, I'm gonna need a coefficient of 3. So I place it here. In the sulfur with a -2, it has a coefficient of 2. So in this sulfur with a -2, I will put a coefficient of 2. Okay. This one, that is sulfur 4, it doesn't have a coefficient, so here I'm not going to write any coefficient. What I do after is I now forget about the charges because I don't need them anymore. And now all I can do is to check if it's balanced, okay? So it's gonna be show sulfur, hydrogen, and oxygen. A ver. Sí, show. Okay, so you're gonna have 2 plus 1, 3 sulfurs here. And in the other side, you're gonna have 3 times 1, just 3. In the other side, you're gonna have hydrogen. 2 and 2 makes 4, and 2. So I'm gonna have 4 plus 2. I'm gonna have 6 hydrogens. And oxygens, I'm gonna have just 3 oxygens. In the other side, for hydrogen, I just have 2, and for oxygen, I just have 1. So that means I just need to balance water. To balance water, and I need to get 6, which means I just need to multiply times 3. Okay. So now I'm gonna have 6 hydrogens and 3 oxygens. And as a result, our equation is balanced. Yeah.
Miss, can you please show how to get the oxidation number on letter 7 on number 7, sorry, of the huge compounds they give us there?
I'm so lazy today.
You promised to show us, Miss.
Wait. So wait. Sarah, your question was?
I just want to know about the oxidation and reduction of exercise 6 because I'm tangled in that one.
Okay, wait. I'm gonna copy better the exercise 6. Okay, and the 7 because I'm this lazy. 6 and 7. Okay. So, Sarah, I already forgot what you said. What did you tell me about the exercise 6?
So funny. About oxidation and reduction.
Okay. So we have the 6, okay? And here we have hydrogen and sulfur. And you have to take a look to the electronegativities. Okay. Which one is going to be negative? Sulfur, okay, because it's more electronegative. You can do it by the electronegativities, or you can just apply the rule for hydrogen by saying
the one of
hydrogen.
hydrogen.
Hydrogen is 1, okay. Therefore, for this to be balanced, 1 times 2 gives you 2, not 1. And then for this to be balanced, I need sulfur to be -2. Okay. Then here I have 1 -2, and I need 5. Okay. If you have any doubt on any of them, tell me. Okay.
No, continue.
Okay. Sulfur alone is 0. Here is -2, 2.
In that case, why use 2 and because
Okay. For this one is the rule of oxygen, basically.
and then to find the difference, right?
Is that the rule of oxygen says that oxygen is -2 unless it is a peroxide, which is not, or that it is combined with fluorine, which this is not the case neither, okay?
+1,
So
right?
oxygen will be -2, okay? -2 times invisible 1 gives you -2. And for this nitrogen to be balanced, nitrogen needs to be +2.
Okay, continue.
Okay. And then in water, okay, that you know is -2 and 1. Okay. So first I notice is that my nitrogen, it was initially 5, and after the reaction took place, is 3. Okay. So here I notice that I have a reduction in the oxidation state. So I say, okay, this is reduction. Now, the other change in the oxidation state that I notice is in sulfur. Okay. Sulfur was -2, and after it was 0. So, like the example with the number line, okay? Sulfur was here initially, and after it ended up at 0, okay? So it was here.
So 2.
And it ended up here. That means that sulfur moved 2 positions. This is the first position, and this is the second position. So it moved 2 positions to the right, which means that the oxidation number was increased. By how much? By 2. Okay. So that means that this is oxidation. So the sulfur is oxidation. Yeah. Is that all you wanted to know? Do you still have a doubt?
No, on that one is clear already.
Okay, excellent.
Miss, I was looking some videos and I see that they were using like a rule to verify if it's correct. And I guess I write it right here. Here it is. It says that to verify, wait, to verify if it's balanced, add all of the charges, atoms on
You
each
are
side.
going to check that it is
In the
balanced by stoichiometry, which means the number of the subscripts atoms, okay, but also by the charges.
this, I find this with the process of the half reaction.
Yeah.
Before putting them in the whole equation, for example, in that one that you're correcting right now. So we compare, for example, sulfur 4 and sulfur 2, right? And we focus on the constants and on the charges, right? So
Oh yeah, take a look
balance.
here in this part that I'm projecting. I have 1 sulfur multiplying 4 plus 2 sulfur multiplying -2. So 1 and 4 makes 4, and 2 minus 2 makes -4, and this is 0. And to the other side, what do I have? 3 times 0, which is 0, so it's balanced.
It's balanced. But I did it. I was trying to verify with these rules, and on number 4, I did it. But when replacing it to the whole equation, it's not balanced. I can't balance.
Bueno, you can send it to me.
It's the one I sent you like from some days ago.
Sorry. Okay.
It's the one that you correct me. I corrected the oxidation numbers, but now I can't balance.
But I did it and I have a good. You see, I have 5 and 0. Okay, 5 and 2 and 0, that makes 0. And then I have 4 minus 3, which is -12. And then I have 10 minus 2, which is minus 20, plus 4 and 2, that is 8. So minus 20 plus 8 gives me -12, and -12 equals to -12. So yes, it's balanced, mine. Send me your problem, okay? So I can check it.
Okay.
But send it to me.
But you cannot do it because I want to see.
And please, you need to be like pushing me, because I get distracted easily by these cats, and also by my sister, and also my mom calls. So you need to insist. It's not that I don't want to reply. Sometimes it's just that I forget because I'm just too old to remember. Emma.
Miss, like on exercise 10, on the half reaction, as a result, I get 6 chlorine. But then at the balance, it suddenly passed to 14 and on the reactant side.
Yeah, that happens. Why does this happen? That happens because in the other side, when you were balancing chlorine, it gave you a total of 14 chlorine, so you need to balance in the end. Okay, so there are a few adjustments that you have to do just because, okay, because you want it to be balanced. So in that case, I had 6 hydrochloric acid, and after the checking part where I check if it's balanced, it was not 6, it should have been 14. So yes, sometimes you need to do some other adjustments. Sometimes it's not going to be just enough by redox.
Can you make that number 10? Just the balancing process. The last part.
Well, I don't remember, but somebody asked me about the 7. Okay. What do you want me to do about the 7? So only oxidation states? Well, nobody asked me about the 7. Well, I'll move to the 10.
Yes, Miss, I asked about number 7.
Okay. What was your question?
The oxidation numbers of the HCO. I don't know how to name that compound.
Okay.
The three
Oxalic,
huge compounds. Yeah.
oxalic acid. This ion is oxalate. Okay, it ends in ATE, so it replaced by ake and then acid. Okay, so the idea is the same. You can do it by just knowing the charge of the, by knowing the ion oxalate, which is this one, okay? You can do it by the ion or by the compound, it doesn't really matter, okay? You want to know what C is, okay? So you say, if you want to do it by the ion, which is what I prefer, because it's simpler, okay? I say, okay, oxalate. Oxalate is C2O4 with a charge of -2. So I say 2 carbons plus 4 oxygens equals to -2. And then I'm going to isolate for carbon. So I say 2 carbons minus 8 equals to -2. 2 carbons equals -2 plus 8. 2 carbons equals 6. Carbon equals 6 divided by 2, which is equal to 3. If you want to do it like mentally, it's also very simple. This is 3. Okay. If you want like to do it mentally, it's also very simple. Take a look. So you have the rule of oxygen giving you -8. Okay. The rule of hydrogen giving you 2. Okay. So you say 8. I do it here like mentally. Okay. 8 minus 2. Okay. Which is equal to 6. And then I divide by the number of atoms and gives me 3. And that's how I get carbon instantly. Y ya. So carbon, when it's in oxalate, it's going to be 3 always. You can do it like this or mentally like that. In the end, the only difference is that you're going to divide by 2 because you have 2 atoms of carbon over here. I don't know if I made it clear or worse. Hopefully.
No, thank you, Miss. You just solved a huge existential problem.
Oxidation numbers in the 5.
Miss, I sent you the picture. Can you take a look, please?
Okay. No sé, where's my phone? Es que somebody called. Ah, ya lo oí.
I'm gonna ring you for you to find it.
No, I already found it. Okay, let me see. Where are you, my friend?